So, what will go in the boxes now? J's and Q's and P's and deltas. What will go here? X goes here. That's what they told you. So what's going to go here? Don't tell me in order. Just the other variables, right? Which one is the output? F. Where do you think F might go? Okay, all right. That's our output, okay? Now we're going to ask ourselves, okay, when are we going to connect F to VDD? Because that's what makes it 1, right? If we have a connection to VDD, that's what makes F 1, right? Okay, so let's see, how can we do that? Oh look, there's a path here, right? Okay, this path is activated through a p-channel MOS, right? Through a PMOS, which means it's a negated channel, right? So what do we need to put here? Z, right? So when Z is 0, this P channel is going to be activated and will connect to 1, right? Okay, well actually that's it, right? We just need to double check that the rest of the implementation is correct, because the only other thing that we're left to put here is Y, right? But now we need to double check what that means. All right, so the other path, if we don't take this path from the output to VDD, if we don't take this path, there is one other path that's defined by this term. And for that path, you have to have X equals 1 and Y equals 0, all right? So where is that path, incidentally? That path is here, right? So let's see if it's activated the way we expect, okay? So when Y is a 0, this is going to be connected, right? But we also need to connect this. If we just connected X directly to this path would activate it when Y was 0 and X is 0, right? But we need to activate it when X is 1. So therefore, the X goes through an inverter first, right? W equals not X. Okay, X goes through an inverter first, and not X. When not X is 0, it will connect this. And because these two are in series, we need to open both of those paths, right? Got it? Okay, so that's it.
What about the bottom? What about the bottom half?
So the bottom, you'd only check if it's complementary, and you'd follow it the same way. Those are n-channel MOSes, and they're activated when you hit them with a 1, right? They make a connection when they're hit with a 1, right? So you'll learn to relate these. That look, there are two paths. There are two parallel paths here on top. For those two parallel top paths, there will be equivalent to series paths on the bottom. Okay. When you switch from P channel to N channel, you also switch parallel paths to series paths. And the reason why you do that is exactly the De Morgan identity, but we really haven't gone through it. Okay. It's this Boolean identity that allows you. In fact, the top and the bottom of a CMOS circuit are fundamentally related by this identity. A plus B naught, the whole thing, equals A naught and B naught, okay? And its complement, okay? So this is what relates you, or what allows you to do it. But what we primarily taught you is to check, okay, whether it's correct. So you can try to practice. For practice yourself, okay? Practice. Instead of the structure given to you here, make a symmetric structure. Symmetric and MOS. And then ask yourself, why does that fail? Okay? So when you practice with this problem, you can make a reflection of it and just connect it just like this, but in NMOS. Wherever there is a series, make it a series, and the parallel paths make it a parallel path. This is not what's given to you. What's given to you is a complementary structure. but try to make a same NMOS structure, and go through the truth table. That will take a little bit of time, but you'll see why it fails. There will be either undefined outputs or you will short VDD to ground. Okay?
Can you discuss more how when you can like stick the circuit like 1/2, and when do you take the circuit as a
When you take a circuit as a whole versus when you break down parts,
Yeah.
you always try to recognize parts of a circuit. So you only take the circuit as a whole. You know, I mean, you can always just do it brute force, but that's last resort. Okay, that's sort of a last resort to just write the truth table and try to do the circuit brute force. Okay, whenever we tackle any problem, we either recognize it as exactly the problem we know, and then we know the solution, or we break it down into sub-problems we know, right? We never really, in any domain, really take a whole big problem and just tackle it whole unless we already know how to do it, right? That's problem solving. You always break it down into sub-problems you know. So that's like, for example, the inverter, right? You can try brute force, but that's not an optimal way, all right? I think we're pretty good with CMOS in general, right, as far as examples. To be fair to other things, we should probably tackle different things, like transistors or diode problems.